So let's look at the example 4 and the evaluating limits of sequences. As usual, you should know that the limit as n goes to infinity of 1 plus 1 over n all power n is equals to e, and that the limit as y goes to 0 of 1 plus y all power 1 over y is also equals to e. So let's keep these ones as we proceed. So wherever we see them, when we do our transformations, we see them, then and just replace them with those ones. So our question is the limit as n goes to infinity of 2n plus 3 all over 2n plus 1 all power n plus 1, like this. And so here there is one thing I can do, because you can write this as the limit n approaches infinity of 2n plus 3 all over 2n plus 1 power n times the limit as n goes to infinity of 2n plus 3 all over 2n plus 1 power 1. See, according to the laws of indices, if the bases are the same, then we add their powers. So we can assume that these things were 2 and they combine them. So for this part we can easily work out the limit. So for that one, you know how to deal with it already. As we go as n goes to infinity, you know, as n goes to infinity, the limit of 2n will be far greater than the limit of 3 as n goes to infinity for both sides. And so with this concept, you can just ignore this man and this man, and take this one and this one. Okay, so we will now have the limit as n goes to infinity of 2n plus 3 all over 2n plus 1 times, and if we have this, that will just be 2n over 2n, and that is 1. So as n goes to infinity, that limit is just 1. So this one times 1, this is power n, sorry, power n. Okay, so right now, as for this part, we can then do our limit transformation, but before we do that, we will first rewrite this. So we now have the limit as n goes to infinity of 2n plus 1 plus 2 all over 2n plus 1 all power n times 1. So here we will have the limit as n goes to infinity of 2n plus 1 over 2n plus 1 plus 2 over 2n plus 1 all power n times 1. So here we get this and this. We get limit as n goes to infinity of 1 plus 2 over 2n plus 1 times 1. Right now, we can then say let y to be equal to 2 over 2n plus 1, but as n goes to infinity, y goes to what? 0. But this is here, n. Okay, and now making n the subject here, we have y 2n plus 1 equals to 2. We just want to make n the subject, so we now have 2ny plus y equals to 2, and then have 2n y equals to 2 minus y divided by 2y, 2y, 2y. So this will go. Therefore, n is equals to 1 over y minus 1 over 2. Okay, so right now we now have the limit as n goes to infinity of 1 plus 2 over 2n plus 1, all power n being equivalent to the limit as y goes to 0 of 1 plus y, all power 1 over y minus 1 over 2, like this. Because in place of the n, this is n, so this one is n, so we replace that with this, and so we have this one over here. So let's see how we are going to deal with this one. So just like the laws of indices, have the limit as y goes to 0 of 1 plus y power 1 over this, all over the limit as y goes to 0 of 1 plus y power half, like this. Okay. So but this is according to the laws of indices. If the bases are dividing each other, we subtract their powers. So since these powers are subtracting, means we have this one here, two of them, one is up and the other one is down, and they are dividing each other, and so they subtracted their powers, and so we can rewrite that one like this. Okay. So by the top part, this part, we know what it is. If we have this, it is already here, we know that it is this one. Okay. So this will imply that we will now have e all over as y goes to 0, we now have 1 plus 0 all power half, and so this will imply we have e over 1 power half, and this is just e as our final answer. Thank you for watching. Kindly subscribe.